evening, students, and in this video we are going to discuss about the binomial theorem. So what is binomial theorem? Binomial theorem is a very powerful concept used in the mathematics, and this is about the expansion. This is also called the binomial expansion theorem, or the expansion of the binomial terms. Now what do you mean by binomial? Is that binomial is generally two terms, like you can say x plus a. This is a binomial because x is monomial and a is also a monomial. So x plus a is a binomial. Trinomial means three terms, binomial means two terms. Now this is a binomial term, and if I raise the power 1, so this is nothing but x plus a. If I raise the power 2, so x plus a whole square, so it means I'm multiplying this binomial 2 times, x plus a into x plus a, and this one gives you the idea of x square plus 2ax plus a square, and this is called the expansion of this binomial term x plus a whole square. Now what about x plus a whole cube? So I have to multiply this whole thing by x plus a, and then I'll get, but you know that we remember this as a formula and we write it as x cube plus 3x square a plus 3ax, or a square x, or if I just maintain the order, then 3x a square plus a cube. Now what if I write x plus a whole to the power 10? Then should I keep on multiplying this whole thing 10 times? It will not become very tedious. So that's why here comes the binomial theorem to make your life easier and very simple. How? Because they have found that if you keep on rotating like the multiplying x plus a again and again, then there is a different and a very weird pattern. So on the basis of that pattern, we get a binomial theorem, and that is called as binomial theorem or the binomial expansion theorem. So I'm writing the full n terms expansion using this formula. Just give me some 2 seconds break so that I clean this. So the binomial theorem goes like this. If I have a binomial term x plus a to the power n, then we will be expanding this nc0. This is the combination of 0 elements out of n things. So nc0 is a term from the combination. I'll explain its meaning. So nc0, whole this power comes on x. So x to the power n and a to the power 0. Now in the very next term, you will have nc1. Then the power from the x will decrease by 1. So this becomes xn minus 1 a1. Order is not important. You can write a to the power n, x to the power 0, or a to the power n minus 1 x. But once you start with that particular order, so I'm taking x as the first term and a as the second term. So nc this one, and nc3 will be x. Sorry, first nc2, n minus 2 a to the power 2 plus, there will be so many terms. Then I write one general term that I call it as RH term. So like this first term, second term, third term, dot dot dot. There are so many terms in between, and then I write the RH term, that is NCR x to the power n minus r into a to the power r plus dot dot dot. Then I go find my nth term, that is NCN x to the power 0 a to the power n. Now just to verify, just to check the add the power of these two, n plus 0 is always n, n minus 1 plus 1 is n minus 2 plus 2 it is n minus r plus r is n, 0 plus n is n. Means the sum of the power of these two, x and a, these two terms, in each and every term is always n. And in the summation form, this whole thing can also be written as x plus a whole to the power n is summation r0 to n, and then we write ncr x to the power n minus r and a to the power r. Summation notation means like starting from r is 0, keep on going to r is n, increasing every step just by 1. And then like suppose if I go for the first term, if I expand, so I write r as 0, then this term will become like this. See, nc0, this is nc0, x to the power n minus 0, that is x to the power n, a to the power 0, this term. Now sum means plus. Then you write r as 1. So nc1, x to the power n minus 1, a to the power 1. Then you directly write r. Then you get ncr, x to the power n minus r, and a to the power r. And then finally, if you go to the final term, that is r is n, then you get ncn, x to the power 0, a to the power n. Now important thing is how you find the value of these nc0s, nc1. So these are the part of the combinations I am discussing, some to remove the doubt. So nc0, the formula ncr, the formula in the combination goes like the combination of r things taken out of n things, and this can be n factorial over r factorial into n minus r factorial. So this is the formula for finding out this term. Suppose if you have to find a term with this NCR, if I have 8c2, then what I'll get 8 factorial on top and then 2 factorial here into 8 minus 2, that is I write 8 minus 2 factorial, and this is 8 factorial over 2 factorial into 6 factorial. Now if you don't know the factorial notations, factorials are like the number 5 factorial is starting from 5, return back to 1, each number decreasing by 1. Like the, you can say that the sum of the first 5 natural numbers all multiplied. So from this order I can write 1 into 2 into 3 into 4 into 5, or you can say 5 factorial is 5 into 4 into 3 into 2 into 1. Now what is 4 factorial? That is 4 into 3 into 2 into 1, that is 4 into 3 into 2 into 1. So you can see that 5 factorial is nothing but 5 into this whole thing, which is 4 factorial. So we find another formula which goes like n factorial is n times n minus 1 factorial, or you can further derive n minus 1 times n minus 2 factorial. So using these notations we try to find the value of these expressions. So I will explain another example. So I have to clear the screen, so just give me a break. So suppose I just try to explain this whole idea with the help of one simple example. You can take anything, like I take x square minus plus 1 over x whole to the power 7. Then what do we get? 7c0 x square to the power 7, 1 by x to the power 0. Then 7c1, I write x square to the power 6, 1 by x to the power 1, plus 7c2 x square to the power 5, 1 over x to the power 2, plus 7c3 x square to the power 4, 1 by x to the power 3. It has to be 7, 4 plus 3, 5 plus 2, all 7. And then I have 7c4 x square to the power 7 minus 3. Directly you can see 7 minus 3, 4, 7 minus 4, 3 here, and 1 over x to the power is 4. Then it all depends on how do you see the things. X square for 7 minus 5, 2 I'll write here, and then 1 by x whole to the power 5. You can interchange. I told you that if you write a first and x first, this does not make any difference. If you write a for a plus x whole to the power n, so you'll get the same thing, but the answers will be something like in the reverse order. And then I'll tell you one more important thing. First, let me complete this. 7c6. So x square to the power 1 and 1 by x whole to the power 6. Then I have, this is 7. So 7. Then I have 7c7 x square to the power 0, 0, and then 1 by x to the power 7. Now just try to find the value of 7c0. What is 7c0? So 7c0 is 7 factorial over 0 into 7. So nc0 is always 1. So this value is 1. This is, and x square to the power 7 is x to the power 14 plus 7c1. Now let me explain this idea of 7 factorial, how I got. So the 7 factorial here, 7c0 will be 7 factorial over 0 factorial into 7 minus 0 factorial, that is this, and 0 factorial is also 1. So this answer will be 7 factorial over 7 factorial, and this gives you answer 1. Now if I go for 7c1, then what will be the value which I'll get? So 7c1 is 7 factorial over 1 factorial, 7 minus 1, 6 factorial. 7 factorial is 7 times 6 factorial over 6. So 7c1 is 7. So you can also take it as a formula like nc0 is 1, nc1 is n. Like 7c1 is 1, 10c1 is 10, 7c1 is 7, 100c, nc1 is n. So this value is 7c1 is 7, and this is x to the power 14. So 7, x to the power 12, x to the power 2 whole to the power 6, 12 divided by x. So it is x to the power 11 plus 7c2. 7c2 is 7 factorial over 2 factorial into 5 factorial. Then you get 7 into 6 into 5 factorial, and upon 2 factorial, 5 cancel. This is 3, 7, 3, 21. So here you are getting 21. This one, 7c2 is 21. 21 x to the power 10 and divided by x squared. So this is x to the power 8 plus 7c3. 7c3 will be 7 factorial over 3 factorial into 4 factorial, which eventually becomes 7, 6, 5 into 4 factorial over 3 factorial is just 3 into 2 into 1, that is 6, and 4 factorial will cancel with this. 6, 6 cancels, this is 35, 7, 5, 35, and this is, we are 7c3, so this is 35. X to the power 2 whole to the power 4 is x to the power 8, and this one is giving you x to the power 3 down in the denominator, so x to the power 8, so this will become x to the power 5. Now you can recognize the pattern, the coefficients from 14 to 11, 3 less, 11 to 8, 3 less, from 8 to this also 3 less. So now 7c4, now just what I was discussing, that the NCR is always NCR minus 1, like 7CR or 7C3. So you see that 7C7 minus 3, 4, these two will always be same. Formula goes like, or you can say that if you just try to write, then this is 7C3, and if you write 7C4, you again get 7 factorial over 4 factorial into 3 factorial. These two are same thing. So this will be just 35. So again I'll get 35, and this way it's x to the power 3 less, so 2. Then I get this term 7c4. I have got this. 7c5 will be very much like 7c2. 7 minus 2 is 5. 7 minus 5 is 2. So 7c2 is 7c5, and this is x to the power 4, and it become this will become 7c5 will be 21. So this is 21x to the power minus 1. So 2 and then minus 3 will become minus 1. Then you have 7c6. 7c6 will be just like 7c1, that is 7. So plus 7, and this will be x to the power minus 4. Now check it out. X to the power 2 upon x to the power 6. 2 minus 6 is minus 4. Now plus here 7c7 will be just like 7c0, that is 1, and this number is 1, so you get 7x to the power minus 7, and this is your whole expanded term. So now this is all about the simple binomial expansion. In the next part we'll just go for the negative term like x minus a whole to the power n, and then we'll discuss few more interesting terms.